Sir, practical of extended ACL only done, but extended ACL is left.
Okay, fine. Okay, so today we will see the practical for extended ACL, and I have already covered the theory.
Your voice is not coming, sir.
Hello, now you all are getting my voice?
Yes, sir.
Okay, fine. Now, I have already covered the theoretical part of extended ACL. And in extended ACL, we have facility that we can define source and destination both network. Fine. If we can define source and destination both network, in that case, we can configure extended ACL at source router. In case of a standard, it is mandatory for us to configure it at the destination router. But in this case, we can configure extended ACL at source router. Okay, first thing. Second thing, in this case, we can stop a specific service also. But there is no facility to stop any service in standard ACL. But in extended ACL, we can stop all services, we can stop a specific service. And the numeric range of extended ACL is 100 to 199 and 2000 to 2000 to 2699. Correct? Extended ACL can also be configured by using numeric value and by using name also. Because for configuration point of view, ACL can be categorized in two categories. One can be numbered ACL and second named ACL.
MDC.
So fine, we will also see both kind of configuration, number-based configuration and name-based configuration of extended ACL. Okay. First of all, for the practical of extended ACL, we have requirement of one scenario. So I'm just going to share my screen. I'm just opening a previous diagram. Okay, in this diagram, um, I have used 11 series IP for router 1 to router 2 communication, and at fast Ethernet interface, I have used 1.0.0.0 network, and at second router, from router 1 to router 2 communication, 11 series network IP, and router 2 to router 3, 12 series network IP. And for this local network, I have used 2.0.0.0 network. Fine. And at third router, no doubt, for our serial configuration, I have used 12.0.0.0 network IP, and for local network 3.0.0.0. Fine. Concept of IP configuration is clear. Is there any doubt?
Yes, sir.
Yes, sir. Look, here I am using this network for this local network, and for second local network, SIP, and for third local network, and from router to router 1 communication, this, and router 2 to router 3.
12.
Fine. Previously, I have used 10, 172, and 192. Now, in this scenario, this is actually I have created this scenario for some other classes. So just I am using this because you all know it well how we can connect to 3 different networks with the help of 3 different routers. And that's why now I have to just show you how we can stop a specific service or a network or a host with the help of extended ACL. Now see, in this scenario, I have used RIP protocol, RIP, routing information protocol, for dynamic routing. And just I'm going to check at first router that this router has all networks information or not in its routing table. At first router, enable, and just to show IP router. Yes, it has all informations. Now, see, here R represents RIP. This is RIP. And RIP, R stands for RIP, and here 1 RIP, 2 RIP, 3. In our scenario, there are 5 networks, 1, 2, 3, 11, 12. Now you all can see that every network information is available in 1, 2, 3, 11, 12. Fine, it means routing table is complete.
Yes, sir.
No other students are responding, only Sasi is responding. What happened, Tabrij, Bullet, Priyanka, Tabrij, Bullet, Prince?
Yes, sir.
Nobody is responding. Neeraj, Ashish, Aryan, Rishu.
Sir. Yes, sir.
You also respond now. Yes, sir. It is clear. Fine. Okay. Now, I'm just going to ping from this machine to just to show you that is okay, fine, this network is okay for data communication. From first machine, ping what 3.0.0.2. I'm just pinging third network one node. Yes, we are getting reply. It means the path is okay. Communication is going on. Fine. Now, to see an example of a service, how we can control service. So just I'm going to configure telnet service at router 3. And with that service, any node of network 1 and network 2 can access router 3 remotely. So first of all, I'm going to configure telnet service at router 3. For telnet servers, just enable and go to configuration mode. First of all, give enable command, enable. I'm going to set enable password, password that will be 123. It's okay. Now I'm going to create one virtual station for telnet, that is line VPY 0. Now password, in this case, 1256. I'm just putting a very simple password because we have to see the output only. And login is required, otherwise no one can log in to telnet service. Now accept. Fine, in this way I have done configuration for remote accessing. Now router can be accessed from any network, any node. Okay, just I'm going to show you that any node is able to access it or not. First machine at command prompt, I'm going to hit command TL and telnet, and then router 3 IP address. Router 3 IP address is 12.0.0.2. Fine. Is this router 3 IP address?
Yes, sir.
Fine. Now enter. Yes, it is asking for password. User access verification password is 456. Enter. Now I can we have router 3 console, and at this console I'm trying to go into privilege mode and ABL enable, but as I have given command enable, it is again prompting me to give password, and we have already set password for enable password, that is 123.
3.
Fine. Now see, I am in privilege mode of router 3, and from this mode I can move to configuration mode also. Yes, I am able to. So for example, I'm going to change the name of router. This is router 3, and now HOSP host and name like CIMAGE CIMAGE. I have given name CIMAGE. Now see, done. Okay, fine. Just exit. Okay, I have done this task through one PC of network 1. Now I'm going to check it at router 3 directly through its own command line. I'm at router 3 and see, this is the name. CIMAGE. It means we are able to configure router 3 remotely. Now we have to stop this. Stop this means we have to stop node for one node of network 1 to from remote accessing of router 3. ओके, रोकना है कि वो जो नोड टेलनेट कर पा रहा है राउटर 3 को वो अब ना कर, करेक्ट ना. For this type of scenario, now this router is the source router, this one is source, and this one is destination. Fine. Now, in case of extended ACL, it can be configured and implemented at source router. That's why we will do configuration at router 1. Fine. Now I'm going to click on router 1, and at this router, I'm just going to configure extended ACL. Extended ACL configuration mode. And first of all, I'm going to configure number-based extended ACL. Okay. Access list 100. This value shows that okay, fine. This is the extended ACL because the numeric range is 100 to 199. Now, what we have to do? We have to deny. What we have to deny? We have to deny telnet service. And telnet service is supported by TCP, transport layer protocol. That's why we have to specify here which transport layer protocol will be applied to stop telnet service, that is TCP. Now, to which node we have to stop? We have to stop host 1.0.02. Fine. And what is the destination IP? So again, host 12.0.0.2. With this IP, 1.0.0.2 has access to router 3 remotely. Okay.
Yes, sir.
Now, with service equal to, here we can write name and we can write a name of service, or we can write port number of service. Here I'm going to write port number. Telnet port number is 23. Fine. In this way, I have just given a denial statement. But as per the previous rule, whenever we specify any denial statement, in that case, we should also give permit statement. Otherwise, what will happen? Any node of first network will not be able to access router 3 remotely. कोई भी नोड एक्सेस नहीं कर पाएगा, इसीलिए परमिट स्टेटमेंट देना जरूरी है. फाइन. सो access list 100, deny, not deny, sorry, permit. And now, here we will not write any TCP or UDP. We have to write permit all IP-based transmission. So protocol is IP, and then for any source node, any. For any destination node, again, any. Fine. The first any represents all rest nodes, and second any represents for any destination rest node. बाकी बचे हुए सारे नोड के साथ में communicate करो. This is a permit statement. Fine. In this way, by putting these two lines, we have just configured extended ACL. Now, after this ACL configuration, we have to implement it as we have done in the case of standard ACL. So where we will configure it? We will configure it at fast Ethernet 0/0 because through this port, first network is connected. So at this interface, I'm just going to implement extended ACL IP access group IP access group what access group 100, and in this case we will write in case of a standard ACL we have written out, and now I'm writing in. Fine.
Yes, sir.
Okay, now fine, we have configured extended ACL and implemented it. Now we have to check it. Now I'm again going to access this router through this node. Fine. And last time we got success, but what will happen at this time? See, trying. It's showing trying. But finally we have information, connection time out, remote host not responding. How remote host can respond? Because your request is not going to the remote host. It is returned back from this interface. Because here we have implemented extended ACL at this interface, fast Ethernet 0/0. Okay, point is clear.
Yes, sir.
Okay, fine. Is there any doubt? I'm just going to bring some light in the classroom because there is a load shedding. Fine thing. Any doubt?
Yes, sir.
Anybody has any doubt? Somebody is trying to mark something? Yes, please. You can annotate this picture. I think you have done it by mistake. Or you are trying to ask something. If you are not able to speak, you can just chat me. You can give your message in chat. Okay, fine.
Yes, sir.
So this is the concept of extended ACL. I think I have written command also on the board, on whiteboard in last theory class. You all have command?
Yes, sir.
Okay. Fine. So please practice it. Now, I'm just going to start new topic, and that topic is NAT. See, Fine, I have just shared my whiteboard. Now, NAT. Address translation. NAT means network address translation. Now, what is NAT? It is used to convert inside local IP address into outside IP address. It converts one IP into another. That's why term translation is used. What type of translation? We have studied translation Hindi to English. Ram aam khata hai. Ram eats a mango. This is Hindi to English translation. But in this case, one IP is converted into another IP. That's why there is an IP translation. And IP here, IP term has been defined as a network address. What is network address? IP address. So IP address is translated, and IP address is translated, but one IP is translated into another. Mostly we use this concept to translate local IP, means private IP, into public IP. Fine. Now, next point, it is mostly used by ISP, Internet Service Provider. Fine, ISP. I will just draw a picture for it. Okay, fine. What is the benefit of this activity or NAT? It saves IP address because with the help of NAT, we can use same network series again and again. एक ही नेटवर्क सीरीज को हम बार बार इस्तेमाल कर सकते हैं क्योंकि ये बदल देता है. ठीक है, अब कैसे उसे समझते हैं. Fine. Suppose this is ISP. Okay, and many users have got connection from ISP. Suppose there are 3 users who have taken connection from ISP. Fine, and all these 3 are routers. I'm just putting some antenna on the router to show you that okay, this is the real router as we can see in case of internet connection. Fine, and with this router we can connect with wired and wireless both devices. Suppose there is a switch, there are many users. In this case also there is a switch, there are many users. In this case also, there is a switch and fine. But in these three cases, we can use same networks. For example, here I'm using 192.168. For example, 1.0 network, and the same network can be used at this point also, 192.168. Here also. Fine. At these 3 points, I am using same network series. Okay. Now, from this range, we always implement one IP address at this interface, router interface, 1.0, 192.168.1.1, and next at node, we configure 192.168.1.2 subnet mask 255.255.255.0 because 192 belongs to class C. And in default gateway, we define 192.168.1.1. So, in this network, the same case. In this network, again the same case. It means in these three networks, we are using same network IP address. But in spite of using same network IP address, all users of these three different networks are able to access internet. How? Because to get a connection from ISP, suppose ISP has configured one IP address at its own end, and from the same series, one IP address we have given to the user as a public. Fine. For this network, it will be 12.0.0.1. I'm just putting an example. It is not surety that we are getting always 11, 12. Fine. And at user end, 12.0.0.2. Now for third network, suppose ISP has given 13.0.0.1 IP for its own interface, and at the user end, 13.0.0.2. Fine. See, from ISP to user, there is a unique IP address. Fine. There is a unique IP address at every station, at every end. Now, and in the inside network, in the local network, every network has the same IP series. Now, then suppose any user of this network, which IP is 1.2, and any user of this network, which IP is also 1.2, and same case in our network 3. If these three users having same IP address and they are requesting for different websites like Google, Gmail, Hotmail, Reddit Mail, Flipkart, Amazon, Myntra, anything, then every user is getting the correct response. If a user has requested for Facebook, it means he is getting a reply from the Facebook server. But every node is trying to hit different websites through the same IP address, and they are getting correct output. How is it possible? Why there is no any conflict? Because NAT is used here. At this router, there is a NAT. At this router also, there is a NAT. And at this router also, there is a NAT. And NAT, what will NAT do? NAT will translate local IP into outside IP. Means here, this network IP address will be translated into 11 series IP address. In second case, local network IP address will be translated into 12 series IP address. And in this case, local network IP address will be translated into 13 series IP address. Now, finally, a request is going to a specific server through a unique IP address. So definitely that server will reply to that unique IP address. And when that reply will come to the specific router, then router will respond to a specific node. A specific node to means to that node who have requested for that site. But this is done by NAT, network address translation. That's why in whenever you see IP address of your machine, most of the time you are getting 192.168. But there is no concept because there is a translation process. Fine. Now concept of NAT is clear.
Yes, sir.
Okay. Now in next class we will discuss about types of NAT. Then we will see the configuration of NAT. Okay.
Yes, sir.
Okay, fine. I'm just going to stop this session. If you students would like to take a screenshot of this note, please take it. I'm giving you 1 minute time. Fine.
Yes, sir.